In this video, we are going to see class 10 triangles. So let's just start with the video. So first we are going to see what are similar figures. So let me just show you two figures first. Consider a circle and another circle. These two circles are called similar figures, okay? They are similar. They look similar. Circles are always similar. All circles are all circles are similar. There is no doubt in that. All circles are similar. Okay. So and then consider here these two figures. When it comes to polygon only, the similarity becomes a question. So for a polygon to be similar, the corresponding angles of the polygons must be equal. Here the angles are equal. Here, here, here. You can see the all angles are 90 degree. All are 90 degree. Okay. And the sides, let it be 3 centimeter. Okay. And if the side of this is 6 centimeter, and let it be 2, and here be 4. Okay, that it is a rectangle, so obviously this will be 3, this will be 6, this will be 4, and this will be also be 4. All will be centimeters. Sorry, 2. This will be 2. So here you can see the sides are proportional. That is, this side, let me mark it as A, B, C, D, and P, Q, R, S. Okay. So here you can see AC by PS, that is 2 by 4. And similarly CD by SR, which is 3 by 6. Both are proportional. 1 by 2, 1 by 2. So the sides are proportional. So for a polygon, it to be considered as a similar figure, the corresponding angles must be equal and the sides must be proportional for a polygons to be similar figures. Remember that similar does not mean they are equal in area and length. Okay. Similar does not mean equal in area and length, that is perimeter. Always. Not always. Sometimes it might be equal, but sometimes it might not be equal. Here the both figures are not equal in area. They look similar. The angles are equal. They both are not equal in area or perimeter. But the figures which are equal in area and perimeter are similar figures. Okay. So when they say they are equal in area and perimeter, those kind of figures, two figures which are equal in area, length, side, etc., both are exactly the copy of another. Those kind of figures are called as congruent figures. Okay, congruent are different. All similar figures are not congruent, but all congruent are similar. Okay, all congruent are similar. So remember that all congruent figures are similar figures, but the vice versa is not true. The vice versa is not true. Okay. Just to see a few more examples to understand similar figure. Here there are two figures. This is a rhombus and this is a square. Okay. Here all sides are 4. Here also all sides are 4 centimeter. Does that mean they both are similar? No, because angles are not equal. When angles are not equal, they both are not similar. Okay, they both are not similar. And there is another criteria that if there are these two figures, so consider this side as 3 or whether it can be 2. Okay, 2. Consider the square of side 2. Here it is a square of side 4. These two are similar. These two are similar. And similarly, there is another square. Let it be square of unit centimeter. These two are also similar. So this is similar to this, and this one is similar to means. That is, the figure A is similar to figure B, and figure B is similar to figure C. A is similar to B, B is similar to C, ultimately implies A is also similar to C. So these are the inferences we draw from the similarity concept. Okay, just remember it. So from what we have seen, we are going to conclude that two polygons with same number of sides are similar if all the corresponding angles are equal and all corresponding sides are in the same proportion. Okay, so remember this, that is, two polygons of the same side means consider two squares. So here it is a square of side 2, here it is a square of side 4. Okay, so when I divide the respective sides length, I get 2 by 4 equal to 2 by 4 equal to 1 by 2. Here it means they are in the same ratio, that is, they are proportional to each other. So if it follows that correctly, two figures follows these two same rules correctly, means they are considered as similar. Okay, they are considered as similar. So we are going to see some important theorem, one of the important theorem of the similarity concept. It is a important theorem of the similarity concept which is known as Thales theorem. Thales theorem, or you can also call it as basic proportionality theorem. So to understand the theorem, we must first do an activity right here. Okay, we do an activity. So consider two lines from a same point. Like here there are two lines from a same point. So mark them as X. So here I mark it as Y and here I mark it as Z. So I divide this XY into unit of one unit. This is 1 unit, this is 1 unit, this is 1 unit, this is 1 unit, this is 1 unit. Okay, that is X A B C D E. Okay, so that means here, since I divided each as each unit is 1 unit, implies XA equal to AB equal to BC and so on equal to EY. Okay, they all are equal in length. And now I am just going to draw a line from E, from this point E to the line XZ. Okay, just going to draw a line. So it intersects at some point. Let me name it as M. Okay, and now parallel to this EM, I am from B. I am going to draw a line which intersects XZ again. So let me name this point as N. This is M. This is M. This is N. Okay. So now here you can say XB by BE is equal to XN by NM. Okay, they will be proportionate. So it is from Thales theorem only. This theorem is called as, it is also called as basic proportionality theorem. Okay, so let's just see the statement of the theorem. So the statement of this theorem is theorem 6.1. It is given as in NCERT book, it is theorem 6.1, and it is given as if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Okay, so we will just see the proof of this theorem in next video. So I hope you guys understand and enjoy the video. Like, share and subscribe Easy Math.